Okay, so we're going to go over some measurement, estimation, significant digits, scientific notation, just some math basics we have to have down before we sort of delve into the mathier part of our physics unit. So there's no getting away from math when you're doing physics. So I want to start with significant figures when we're measuring something. So if you look down here, we're going to be using this, and this is all in your handout. I just wanted to just kind of go over it. This is going to be your measuring tool. So this tool is 1 unit long. Now the handout says we're going to be measuring your pen. No, we're not, because most people's pens are going to be bigger than this measuring unit. So I don't know why they came up with pen. Let's measure our pinky finger up to the knuckle, and then I'll talk about how the significant figures work. So when you're measuring something, the significant figures is the number of digits that are known with certainty plus the last one that is not absolutely certain. You're always going to be estimating sort of that last unit. So if we look at this measuring tool and you take your pinky finger and you line it up into the knuckle, you know for certain it is less than 1 unit long. Hoping yours is. Mine certainly is. It's less than 1 unit. So the 0 point, and then we're going to estimate where that knuckle lands. So I'm certain about the 0, but I'm really not certain. I'm certain it's less than 1 unit. I'm going to estimate it at 0.6 units because I'm definite. Oh, I guess a pen would be. I am most definitely past the halfway point with my knuckle. Okay, so when I say, okay, my measurement has how many significant figures, it really only has one because I estimated the 0.6. I definitely know it's less than 1 unit, but that second figure I'm unsure of. Okay, and then if we change our measuring tool and give it a little more accuracy, so now I can be a little more accurate with my measurement, but I'm still going to be doing some estimates. So I'm going to lay my pinky finger along here and count 2, 3, 4, 5, 6. Okay, I'm going to say my knuckle is landing right halfway between the 6th and 7th line. So now I'm certain about it hits the 0.6, but my last, I'm going to say is about halfway, 0.65. So now I'm certain about the 0 and I'm certain about the 0.6, but the 5 I'm not certain about. So this is 2 significant figures. And then I don't know what happened to this last one. Really don't. That's not going to look like the measuring tool in your handout. When I opened this up in my app that allows me to write all over it and talk at the same time, it did something weird here. So I will leave you to do this last one with your pinky finger using the actual worksheet, and you should be able to come up with something that is 3 significant digits. So some rules for significant figures, and really in physics, if you don't do it for a while, you have to look these over every time you start physics over again, because you're always going to be dealing with these when you are doing physics. So here are some rules for significant figures that are critical in reporting scientific data, okay? Because they give the reader an idea of how well you could actually measure or report your data. Okay, just 1 second here. Everett, I'm just in the middle of something. You can make popcorn. I don't want any, but thank you. Okay, so any 0 bound by 2 non-zero digits is significant. Okay, so when we look at 403, all 3 of these numbers are significant because the 0 is bound by non-zero digits. Okay, and when we look at 2304, again, that 0 is bound by non-zero digits, so all 4 of them are significant. It's when we start or end with zeros that things get a little weird. So any 0 to the left of the first non-zero digit is not significant. So here's our first non-zero digit. Everything prior to that or to the left is not significant. So this one has 3 significant figures. If we look at this one, there's a 0 in it, but that one is bound by 2 non-zero digits. But everything from that first non-zero digit into the left is not significant, so that leaves us with 4 significant figures. And probably when you practice this, you're going to have to look back and forth to remember these. We just don't use them that often. Any 0 to the right of the last non-zero digit is significant if there's a decimal. Okay, so if we look at this first one, 3,400 kilometers has 2 because there's no decimal. But if we suddenly put a decimal in there, 3,400.0 kilometers, all of that is considered significant. Okay, so any 0 to the right of the last non-zero digit is significant if there's a decimal. So all 3 of these zeros here, because of the decimal, are significant. None of these are because there's no decimal. Okay. Addition or subtraction, the number of decimal places in the answer should be the same as the least number of decimal places in any of the numbers being added or subtracted. Okay, so this number has 2 decimal places, this one has 3. So when you add those, you get this number, but you have to round it because this number only has 2 significant digits. So we always have to go with the minimum number of significant digits that are being added or subtracted. So because it's 0.75, anything greater than 5 means round up. So the proper answer is 5.8. And multiplication and division, the answer contains no more significant figures than the least accurately known number. Okay, so this has 4 significant digits. This has 2. This is the least accurately known number because there's only 2. So when we multiply, our answer can only be 2 significant digits. So we must round that to 3.7. Okay? And counted values, when you know exactly how many you have of something, then you have infinite significant figures. So if you can count things, they're all significant. Okay? So anyway, refer back to this page as you go through and do these questions. And if you have any issues, just ask, and I will help you with them. And we're going on with one more little review of mathy type things tomorrow, and then we're going to move on.